Hello, Algebra 2. Here's your agenda for Tuesday, 4/27. We're going to do notes 46 on graphing exponential functions. At the top of your page, label notes 46, and the essential question is, what are the steps to graph the base exponential functions? Your goal is that you can graph an exponential function using a t-chart and know how to approach an asymptote line for proper graphing techniques. So there's 3 problems on the last slide of this presentation. You'll need a separate piece of paper for assignment number 47 for homework. Okay, so just so you know, let's look at the graphs first. So these are pictures of exponential functions. One's a growth on the left in red, and the one in blue on the right is decay. You'll notice that the red graph and the blue graph have a smooth curve, arrows on both ends. Let's see, my pen doesn't want to work here. There we go. Then also please note that we're introducing the idea of an asymptote line on both of these. The equation for that line is y equals 0, but what that means is the asymptote line is actually this x-axis. So the thing with exponential functions is they never cross, they just come really close to the asymptote line. And in this case, for today, the asymptote line is the x-axis. So make sure you don't cross the x-axis, that your graphs just come really close. And then also, please note that there's an anchor point of 0, 1. So that's the one dot that we've drawn on these graphs, 0, 1. Okay, and you'll see how that comes into play as we graph. All right, so for graphing exponential functions, today we're going to do the base function. So please write that down. Please copy down your steps, hit pause, and as soon as you're done, and come back to this video. Okay, so your steps are to draw a t-chart. For the x in your t-chart, you're going to start at 0, 1, 2, 3, and then 0, -1, -2, -3. We're going to plug in the x values to get y and then plot the points. We're going to draw arrows on both ends. We're going to use a smooth curve, and don't cross the asymptote line. And for these graphs today, that's the horizontal line y equals 0, which is the x-axis. So don't cross the x-axis. Okay, just so you know, this is going to be your page setup. So take a minute and look at this and listen to me for a second. We're going to be doing 3 graphs. So you're going to need 1, 2, 3 grids and 3 t-charts and room for calculations. So if you want to take a minute to draw them out separately and then come back to the video or draw them as we go, we are going to be doing 3. Okay, so let's get started. Here's the first one. So the first thing I want you to do is to write down this equation. F of x is equal to 3 to the x. Now in this case, the base, the b that is hooked to the x, is going to be 3. So 3 is the base, and we're going to see that this is going to be a growth graph because of the 3. All right? And we'll talk more about that in just a minute. The a in this case is a hidden 1, but you don't need to know, you don't need to write that down, okay? But the a is a hidden 1 this time. Okay, so let's get started with drawing our t-chart. So we have x and y. I told you what to pick for the x. So we're going to pick numbers next to 0. So 0, 1, 2, 3, 0, -1, -2, -3, right? And then we plug it into the x, and out will come y, right? So plug it in. So let's start right here at 0. 3 to the 0. Then we'll do 3 to the 1, 3 squared, 3 to the 3rd, and then we'll come and do the negative ones in just a minute. Okay? What is anything to 0? Do you remember from your exponent rules? Anything to 0 is 1. So when we plug in a 0, we get 1. Here we plugged in a 1 for the x, right? So 3 to the 1 is just 3. What's the next one? 3 squared, 9. What's the next one? 3 to the third. 3 times 3 is 9 times 3 is 27. Okay, now we have to do our negatives. 3 to the negative 1. 3 to the negative 2. 3 to the negative 3. Write those down so you have some good math on your notes. Okay, what do we do when we have 3 to the negative 1? Do you remember what your rules are? You're supposed to dive it down. Remember, we're supposed to dive those down, right? Supposed to dive them down. Remember those rules? Okay, 3 to the negative 1 means we dive it down. Well, 1 over 3 to the 1 is just 1/3, isn't it? What about 3 to the negative 2? Dive it down. Well, in this case, 1 over 3 squared is 1/9. 3 to the negative 3, dive it down. When you dive it, you make that exponent positive. 1 over 3 to the third is 1 over 27. Okay, just so you know, 1/3 is bigger than 1 out of 9. The smallest is 1/27. So 1/3 is bigger, 1/9 is less, 1/27 is even smaller. Okay? All right, let's plot these. Let's start at our anchor point, 0, 1. 0, go up 1. Let's do 1 over 1 up 3. Over 1 up 1, 2, 3. Next one, over 2 up 9. Over 2 up 9. And over 3 up 27. So that one goes off the grid, so I'll just put it there so I can reference for when I graph it. Okay, now let's do negative 1. So left 1 up 1/3. Left 1 up 1/3. So we just estimate that. Next one, negative 2 1/9. Left 2 up even less. Negative 3 1/27. So it's getting closer and closer to the x-axis, but it never touches it. Okay, so if you were even to plug in negative 4 or negative 5 or negative 6, this would still keep giving you a fraction. It would never get to 0, which is this asymptote line at 0. Okay, so it just keeps getting to be a smaller fraction. So I'm going to try and draw my smooth curve now. Takes me a second. There we go. And then I'm going to draw it this way. And I just approach that asymptote line, and I never quite cross it. Sorry, mine got a little bit wavy there. But please make sure it is a smooth curve. Do not draw this. This is wrong. Don't do that, okay? No bends. It has to be a curve. All right. So main points of this one. Because you have a 3 to the x, it's a growth curve because of this 3. Let's do the next one. Okay, write down this equation. Okay, because we have the base, the b, hooked to the x as a 1/2, this is going to give us a decay. So anytime your base is 1/2 as a fraction, you get a decay. So our graph is going to fall. So you should write down f of x is equal to 1/2 to the x. We're going to fill in our t-chart. And we're going to get started. Okay, I'm going to start right here in the middle. So what is 1/2 to 0 after that? Because remember, you're just plugging in for the x. 1/2 to 1, 1/2 to 2, 1/2 to 3, and then we'll get started. Anything to 0 is 1. 1/2 to the 1 is just itself. It's just 1/2, right? Okay, 1/2 squared. So what do? We have this as a 2. Remember, you distribute that. Okay, same with the 3. We're going to distribute the exponent to tops and bottoms. We went over those rules. So that would be 1 squared over 2 squared. That's just 1 over 4. Okay, next one. That's just 1/3 over 2 to the third. 1 to the third is 1 times 1 times 1 is just 1. 2 to the third is 2 times 2 times 2, which is 8. Okay, now we have to do the negatives. So 1/2 to the negative 1, 1/2 to the negative 2, 1/2 to the negative 3. Okay, what happens when we have a negative exponent? We're going to distribute that just like we did with the other ones up here. So let's distribute your exponent. So this would be, pick up a different pen, 1 to the negative 1 over 2 to the negative 1. What happens when you have a negative exponent? This one dives down, this one moves up, right? Isn't that what we do with a negative exponent? We move them. So the 1 dives down, the 2 dives up. To the first power, I don't have to write. What's 2 over 1? Just 2. Let's do the next one. Distribute your exponent. 1 to the negative 2 over 2 to the negative 2. When you have a negative exponent, this one moves up, this one moves down. So 2 squared moves up, 1 squared moves down. That's just 2 squared is 4. 4 over 1 is just 4. So basically, we're just flipping it, aren't we? The last one would be 1 to the negative 3 over 2 to the negative 3. Negatives mean I need to move the item. So that's 2 to the third over 1 to the third. 2 to the third is 2 times 2 times 2, which is 8. 8 over 1 is just 8. Negative exponent means you just kind of flip them over, right? Okay, let's take a look at a pattern before we graph this. Look at this for a minute. Let me make your math easier. So here we are at our anchor point, and then we go 2, 4, 8. And then we have 1/2, 2, 4, 8. 1/4, 1/8. 2, 4, 8. 1/2, 1/4, 1/8. That's a pattern you should see. Look at the next one. Here was our anchor point. And then we had 3, 9, 27. Down here, 1/9, 1/27, and 1/3. Sorry about that. 3, 9, 27, 1/3, 1/9, 1/27. So that's a pattern that comes up that'll help you with your math. All right, we got to go ahead and graph these now. Let me get rid of the eraser. Okay, so let's graph our anchor point of 0 up 1, over 1 up 1/2, over 1 up 1/2, over 2 up 1/4, even less, over 3 up 1/8, even less. And do you see how this is going to become a decay? It's going to fall down the graph, and it's going to approach this asymptote line. Let's do the other one. -1 up 2, left 1 up 2, -2 up 4, and -3 up 8. Should be right here. So you see how your graph is falling? This is a decay model. It's decaying. Arrows on both ends, and a smooth curve. Approaching the asymptote and not touching it. I kind of missed that dot, but that's not a bad looking graph, so I'm going to leave it. Please try and make sure you hit your dots. It's harder for me on this screen. One more, you guys. Okay, So how is this one different? Our base is 3, so it's still going to be a growth as long as your base is a regular number. Remember, when this is a fraction, then that's when you have a decay, because we did this one with the 3 already, and we had the growth, right? But this one's different because our A value is worth 4. That particular shift just means that it's going to stretch our graph. It's going to make our Y values bigger. So write down this function. Put in your X values. And let's start plugging in the X. So we're going to plug in, I'm just going to write them all out. 3 to the third, then we'll do when your exponent is a 2, when your exponent is a 1, 0, a -1, a -2, and a -3. So we just plugged all of those in for X, right? And then we'll do the math. Okay, let's start at the top. PEMDAS rule says do your exponent before you multiply. So this is 4 times 27 because 3 to the third is 27. You have to do that first. That's 108. Okay, next one. You have to do the exponent first. 4 times 9. That's 36. Have to do the exponent first. That's just 4 times 3. That's just 12. Okay, 4 times 3 to the 0. How much is 3 to the 0? 1. Anything to 0 is 1, so this is just 4. So our anchor point has changed. Usually that point is 0, 1. Now it's 0, 4. Okay, 4 times 3 to the -1. This has to dive down, right? Because it's a negative. So 4 times, dive it down, 1/3. 4 times 1/3, just make it look like a fraction and go straight across. That's 4/3. Now, how do you graph 4/3? That's an improper fraction. We need to make that into a mixed number. 3 goes into 4 once with 1 left over. So when we graph this, 4/3, we have to graph it at 1 and 1/3. Because that's how much 4/3 is. It's 1 and 1/3. How many 3's go into 4? 1. What's left over? 1/3. Okay, let's do the next one. Remember to dive this down into a fraction. 4 times 1/3 squared. That's 4. Whoops. Well, I could put 4/1. Times 1/9, which is 4/9. We don't change that to that's not an improper fraction. This 4/3 is improper because 4 is bigger than 3. So 4/9 is getting smaller. Next one. 4 times, remember to dive this down, 1/3 to the third. That's 4 times 1/27. So that's 4/27. Because 3 to the third is 27, right? Okay, here's our pattern, right? Filled in T-chart. Let's graph it. Okay. So let's start at the anchor point. 0, 4, 0 up, 1, 2, 3, 4. Let's start here. -1 over 1 and 1/3. -1 up 1 and a little more. Next one. -2 left 2 up a little bit. 4/9 is not greater than 1, so you can't go above 1. -3 up even less because 4 out of 27 is smaller than 4/9. Okay, let's go over here. Over 1 up 12. I'm already off the grid. Over 2 way up 36, and I can't even graph over 3 up 108. It's off the chart, really, So what did 4 do? So when we had this equation here, what did that value of 4 do? It stretched our graph. It increased the y amount by 4 because 4 times the function, right? So it stretched the graph up. It still swoops down and is a growth. So it's still a growth, but it stretched it up. Okay? All right, watch the next slide. So this is your homework. Make sure that you show your t-charts. Your asymptote line that you're dashing in is just this x-axis. Make sure your graphs do not cross over the x-axis because that's what's called your asymptote line. And make sure you use a smooth curve with arrows. All right, graph those 3 for homework. Thank you.